Typically, the B lessons are not that involved. They're usually just an extension of the lesson that they're related to. But this B lesson, special functions, is actually quite involved. So I'm gonna split it up into two different videos. One video is going to be what's called piecewise functions, and then the other video is on absolute value functions. So you make sure that you watch both videos. A piecewise function is defined by two or more equations. Each piece of the function applies to a different part of its domain. This is what a piecewise function looks like. Normally we see y equals and then one expression over here, but a piecewise function says, well, it depends on what your x value is. If your x value is either 0 or negative, then this is the equation, and if your x value is positive, this is the equation. So it's really like kind of like an undecided function where it's like, I don't know which equation to be. So this is what a piecewise function looks like. And we use these fancy brackets that I think we've practiced in the past before. If we haven't yet, then we'll practice them when I see you next. So this is what this piecewise function really represents. So this 2x plus 1 part relates to this line. When the x values are positive, the x values are this, the domain. When the x values are on the positive side, then that's the line you look at. When the x values are on the negative side, that's the line you look at. Now, typically, the function is not always centered at the 0. It can be centered at other values, so I don't want you to think it's always centered at just the positive or negative 0 split. So let's look at graphing a piecewise function. Let me make my grid first. And then we're just going to do one piece at a time. Please have a pencil handy because we will be drawing lines and erasing parts of them. If you look back up here at the example, you see that it's kind of like half the line is missing. Like this line just kind of stops at 0, where typically we would continue it. This line begins at 0, and we're going to continue it, or we would continue it. So you'd need a pencil with a nice eraser to do this kind of lesson. So first thing I want to do is I want to graph this first equation, negative x minus 4, and it's going to be graphed in the negative x values. Now we're just going to start off where they're centered around the y-axis, but again, they won't always be centered around the y-axis. So go to graph negative x minus 4, just like you would typically. So it's going to be an intercept at negative 4, and the slope is negative 1. So there's the line, do a couple of points, connect them, no big deal. Don't label it yet. But what this is saying is that the only points that matter to me are the ones where the x value is less than 0. So I don't care about this whole section right here. And technically, I also don't care about the 0. This whole section I want to erase because the only values that matter to me are where the x value is negative. I remember x value is the horizontal. So I'm going to erase this whole part of my line, and I'm also going to change that 0 to an open circle because I'm not technically, according to the rules, allowed to include 0. So I'm using all the negative numbers here, and then when I do the other one, I'll get all the positive numbers, including 0. So this line shows me that it's the line negative x minus 4, but it only includes negative x values. All right, now let's go to the other one. Now I'm going to graph this simple line y equals x, just like I would normally. Intercept is at 0, put a bunch of dots, and graph it like you would before today. But the directions are telling me that I only care about where the x value is greater or equal to 0. So this whole section I don't care about because I only care about the part where the x values are greater than or equal to 0. So I'm going to erase this whole section right here. Now, as you get more advanced with these, you won't be drawing and erasing. You'll just be knowing where to start. But for the first couple, and even for a while, you probably will want to just draw the line and erase. So this is what it should look like. It should also pass that vertical line test that we did, where we draw those vertical lines and make sure that the graph doesn't hit more than one line at any particular point. And we have to describe the domain and range. So I'm going to take my lightsaber and I'm going to scroll across the x-axis, because that's the domain, looking for places where the graph doesn't exist. So like if I'm all the way out here, I will eventually hit the blue graph because it would at some point be up here. So as I scroll across the domain, I don't see any points where I wouldn't hit the x-axis, right? Because every graph is either visible or like out here, it would be up here somewhere. So the domain is all of the numbers. What we do is we write domain, and then we write that it equals all real numbers. Now, I say real numbers instead of just all numbers because I want you to get used to that phrase. In Algebra 2, you're going to be learning about these things called imaginary numbers. And so for now, it seems dumb, but real numbers are just the calculator numbers, the numbers that we've experienced. So I just want you to get in that habit, but it doesn't necessarily mean anything different than what you already know. In math, we like to use symbols to represent phrases and words. So we have this symbol for the phrase all real numbers that you can certainly use. It's two little lines like this, but then you turn that into a capital letter R. So that symbol represents the real numbers, or just the numbers, the numbers that we're used to. Now we try and find the range. So I do the same thing, but now I go across the y-axis. So I scroll up and down the y-axis and I look for a spot where I wouldn't have any of the graph. And that would actually happen down here. There's no graph underneath -4. So the way that I would say that is I would say the range is all real numbers, but they have to be greater than -4. It can't be equal to because there's actually no value here. So the range is the y values that are greater than -4. Let's just create the equations that made up this piecewise function. So pretend the lines are extended, and then we'll just worry about what the domain and range are. So let's look at, I'll just call this one A and this one B. So let's look at A. First thing you do is you write your y equals, and you get your little fancy parentheses open. Line A has an intercept of 3 and a slope of 1. So that's the line y equals x plus 3. We'll take care of the domain in a second. The other graph, line B, has an intercept of -1 and a slope of 2. So those are the two equations that are made up of my graph. Now I'm going to go back and I want to look at what's not being included. In the first equation, this section right here is only part of the graph, and that's where the x values, see how x is here, x values are negative on that graph. So I'm looking at x is less than 0. It's not equal to 0 because we have that open circle right up here. Now we go down here. It's usually the opposite, but if you want to look, see I'm including 0 here, and if you go along the x-axis, this line uses all of the positive y or x values. So this is going to be x is greater than or equal to 0. There's an important type of piecewise function. It's called a step function. And a step function is a piecewise function defined by constant values. The graph of a step function consists of a series of line segments. So let's see what that really means. So we've got this karaoke machine for 5 days, and they're charging us $50 for the first day, $25 for each additional day. So we've got to write and graph a step function. Now I'm going to keep us in the first quadrant because I can't have negative days or negative dollars, so it makes sense to stay here. So this is the constant values. It's saying that if x is between 0 and 1, it's always going to be this number. If x is between 1 and 2, it's always this number. 2 and 3, it's always this number, etc. So let me make my graph, and just for simplicity, I'll go by 25s. And so that means that open circle, when x is, it's not quite 0, but it's close to it. So open circle around 0, and I'm going to stop my line at 1 because that represents the line y equals 50, but it's only the line y equals 50 from 0 to 1. Then I'm going to graph the line y equals 75, but I'm only going to include the values between 1 and 2. Then I'm going to graph the line y equals 100, but I'm only going to include it between the values of 2 and 3, and etc. So I've got 3 to 4 and 4 to 5. Make sure you have your open circles. Write a graph, a step function that represents the relationship. So it's going to look kind of annoying, but you know, piecewise functions aren't super friendly to write. So here we go, y equals. Now I have the line y equals 50, but it's only when 0 is less than x, which is less than or equal to 1. Then I've got 75, but it's only between 1, that's not supposed to be there, and 2, and so on. So that's what my piecewise function looks like. And you don't usually label on the graph, you usually just write it off to the side because there's a lot of graphs involved, or a lot of equations involved. And there's one other type of function that I'd like to teach you about, and that's called absolute value functions. So I want you to, if you have any questions, write them down about piecewise functions. And when you're ready, check out the absolute value video that is also part of this lesson as well.